We have our original C code, synthesizable C code. Uh, we can s- see the synthesis results with synthesis window here. We can see that it's at 704 and the area ALUT. Now to this code, we will add the pragmas. Now I've added three pragmas to the C code, synthesizable C code. One in front of the array where cyber array is set to the RAM and cyber unroll times is set to all near the two for statements, two loops. This was synthesized and the synthesis window was obtained. From the synthesis window, we can see that the ALUT is reduced. This happens because when the latency increased. This happens because as we can see we have utilized RAM, which means instead of ALUTs, the design the synthesized design makes use of RAM, which we can see here. The block memory bits is not zero, which means that RAM is being utilized and ALUTs are not used anymore for storing there. Now for the Now, for the second design where our pragmas are set this way for array, we're using registers and we're making the first loop unruled, but the second loop is not unruled, and this is synthesized and the synthesis window can be seen here. We can see that the area increased, the ALUT is increased. This is expected since we increased the number of logic fabric and the path delay decreased. It makes sense because previously the RAM doesn't support unrolling because it does not allow multiple accesses, but with registers it's definitely possible. So we can see that our critical path reduced compared to the first design where even though we've unrolled both the uh, for loops, the RAM is limiting that unroll. So in our third design, we've made the second loop unroll as well, and we're still making use of the register arrays. This has been synthesized, and the synthesis window is can be seen here. Our area and latency went back to our original design, which suggests that by default, the loops are set for unroll and the registers are used for the array, and it it makes sense that the ALUT is increased because we're making use of parallel operations for the iterations in the for the loops, and we're making use of LUT logics for the array operations.